Okay, so now let's get into something which is important, which is the sigma notation, but we are going to get into it in just a second. Now I want us to first look at how the relationship between the general term and the sum of their series. Okay, so let's look at the series, which is going to be 3 plus 7 plus 11 plus 15 plus ... Okay, I want us to look at the series, and I want us to calculate the general sum of this sequence, of this series. So the general sum. So we are going to first find the difference of this and say this is going to be 4 and 4 and 4. We want to find the general sum. But before we find the general sum, let's first find the general term. Okay. But I'll show you why we need the general term for comparison at the end of this experiment that we're doing. Okay, so let's find the general term of this. You can easily find it. You are going to get that this is Tn equals to 4n minus 1. So that's the general term of this series. Okay, but now let's find the general sum of this series. Please try and calculate it and choose the correct answer. Okay, so it's a very easy process. First we write our formula. So Sm equals to n over 2 2a plus n minus 1. That's just our quick formula that we are going to use. Then we substitute n over 2. A is just 3, so this is 2 times 3, okay, and plus n minus 1 times the difference, which in this case is 4. Okay, so as you can see, we leave n as it is. We are not substituting anything because we want the general sum. Just as when we are calculating the general term, it has n in it, so the general sum will have n. Now then, that's going to be n over 2, which is going to be 2 times 3, which is 6, plus 4 times n, that's going to be 4n, 4 times negative 1, that's going to be negative 4, and then that's going to be n over 2, 6 minus 4, that's going to be 2, so this is going to be 4n plus 2. Alright. So at this point we are going to be multiplying by n over 2 inside. Okay, and then we are going to get that n over 2 times 4n, that's going to be 2n squared. Why? Because this half is going to divide 4, and then we're going to get 2, and n times n is going to be n squared. N over 2 times 2, that's going to be just n. So this is the general sum of this series. Now using this general sum, we can therefore calculate a lot. As we did, we can calculate as 20, we can calculate as 11, anything by just plugging these values in here. Okay, right, so this is the general sum of this series. Okay, now as part of our experiment, I want to try to find as n minus 1. Okay, as n minus 1. So when we are doing as n minus 1, we are going to substitute n minus 1 whenever there was n. That's what we are going to do. But be careful, what we don't want to do is we are not going to say 2 n squared minus 1 plus n minus 1. This is wrong. We're not going to say it, do it like that. But we're going to substitute inside the bracket. Alright, so try to find Sn minus 1, and then we are going to compare with the solution that I'm going to give. This is how we're going to do it. This is going to be 2, and we are going to have brackets squared plus brackets like that. Okay, so we are going to have n minus 1 here, and then n minus 1. So that's how we substitute n minus 1 to this formula. Okay, then this is going to be n squared minus 2n plus 1. Where did we get that? We just distribute from this bracket, plus n minus 1, and then this is going to be 2n squared minus 4n plus 2. How do we get that? We just transpose 2 inside the brackets, plus n minus 1. Alright. So as we can see that we are going to have, okay, so this is going to be 2n squared minus 3n plus 1. So this is Sn minus 1. Okay, this is the answer for Sn minus 1. Now, as part of our experiment, again, we now want to find Sn minus Sn minus 1. Try to compute this. Take Sn minus Sn minus 1 and see which answer do you get. This is going to lead to some interesting conclusions. So Sn is 2n squared plus n, and then Sn minus 1 is 2n squared minus 3n plus 1. It's very important to use the brackets when we are dealing with subtracting expressions, so because they are negative numbers, so that you can actually see how things are going to go. Alright, so let's just compute that. This is going to be 2n squared plus n minus 2n squared plus 3n minus 1. So what we see, this will cancel that, and we are going to be left with n plus, this is going to be 4n minus 1. This, as you can see, is equal to Tn. As you can see here, these are equal. What does that mean? It leads to an important conclusion that Sn minus Sn minus 1 is equal to Tn. This is a formula which is very important that we are going to use. So if we have the general series, which is in this case Sn equals to 2n squared plus n, we can find Tn just using this. We can find any term. For example, if we want to find T4, we are going to say S4 minus S3. Since if this is 4, this will be 3, since this has minus 1. Okay, and in that case, that will just be substituting 2 times 4 squared plus 4 minus 2 times 3 squared plus 3. This is S4, this is S3. Which is going to be 15. Alright, so this is 15. Let's try to compare to T4 from our series. So as you can see, 1, 2, 3, 4, indeed that is equal to 15.